So, now let us see the thermal radiation and its properties. So, it is the mode of heat transfer, in which heat is transferred from one region to another region without intervening the medium in between. There is no requirement of the medium in between them. It is the fastest and universal mode of heat transfer. Now, let us see the properties of this. Properties. What are the properties of this? So, number one property, all solids and liquid surface emit radiations at all temperatures. Gases also emit, but the radiation emitted by gases will be different and we won't study now here. So, what radiation we are talking about, that is the infrared radiation that largely comes from the surface of solids and liquid. Second point, these radiations are electromagnetic waves and occupy a small window of 0.1 micrometer to nearly 100 micrometer in the electromagnetic spectrum. So, a small portion of the electromagnetic spectrum is in this. Let us see, this is my electromagnetic spectrum. So, here center, this is 10 to the power 0 and this is 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7. These are all in micrometers. So, here last I have written micrometers, and again here this is 10 to the power minus 1, then it is here 10 to the power minus 2, then here 10 to the power minus 3, here I have 10 to the power minus 4, 10 to the power minus 5, here 10 to the power minus 6, and then here 10 to the power minus 7. So, now you see here this 0.1 micrometer to nearly this range. So, this is the range from here to 10 to the power minus 1. So, you can see this range. So, this is the range of this entire spectrum. I call this infrared, or this is the thermal radiation. This is actually infrared, not only infrared, others are there. So, we are this entire spectrum will be thermal radiation. Now, this is here. So, beyond this, here you have first X rays and then here you have gamma rays. So, gamma rays are short wavelengths, and here you have beyond this you have microwaves, radio waves and microwaves. So, these are beyond this. Thermal radiation lies a small window of this 10 to the power minus 1 to 10 to the power 2, you can see 0.1 micrometer to 100 micrometer. Now, you see visible light is within this. So, you can see where is the visible light. Visible light is nearly you can start with visible light has from nearly 7000 angstrom to nearly 4000 we can take angstrom. This is for violet and this is for red. So, entire red to violet will be here. So, violet will be 4000 angstrom means 0.4, you can take this as here. So, very small window, from this to this you can take this is visible light, visible light. So, visible light is here only. So, what thermal radiation we are talking about extend. So, visible light is a part of this radiation and it extends up to 10 to the power minus 1 to 10 to the power 2. So, this region of spectrum carries most of the energy and they are thermal radiation. These are more energetic radiation, but we do not call it thermal radiation, and so only thermal radiation is from this part only. Now, let us plot the dependence of this thermal radiation on the wavelength. So, you see we have a graph, this is the graph we plot. So, where alpha is there and here we plot the intensity of the emitted radiation. So, the graph comes out to be like this. So, it decreases asymptotically. So, you see any body radiates all wavelengths with varying intensity. So, here the area under curve, the area under the curve represents the total emitted radiation. Now, you see total emitted radiation means entire spectrum is there, that means 0 to infinity. What is important point is that most of the energy lies within this. So, you see this is the region where 90% of the energy lies in this entire region. This is 0.1 micrometers, not angstrom, micrometers to 100 micrometers. So, this is the region. So, within this boundary we have most of the energy. So, when we talk about thermal radiation, we generally draw up to here to here. We are bothered about this graph only. So, now this was third. Now, in addition to emitting radiation, any surface can absorb radiation falling on it. So, not only any surface can radiate radiation, it can also absorb radiation. So, these are the properties of thermal radiations emitted by any solid or liquid surface.